Hey, this is Sheldon McDonald here with another episode of exploring 6809 assembly. Today I'm just going to go over a few things with like how you would do gotos and gosubs within assembly language. And we're going to finish that mouse cursor program I did on the last episode. And we're going to make it use a high-speed interrupt. Okay. Actually, it's not the high-speed one I'm using the slower one. Okay. And it's actually the same interrupt that I use for my music software to play in the background of BASIC. So there's actually a lot of things that you can do with it. Okay, so if you go online, you can find the same files I'm looking at. We'll go to www.smotion3d.net and you'll go to the ASM tutorials, and this one you can see I've named it differently. Now that I see how this is loading, I'm probably going to put a 3 in front of exploring so you know which episode it actually is. This would be the one that you'd be downloading that I'm talking about today. Okay, except I'm just going to relabel that so it's a little easier to find. Okay. Alright, so exploring 6809 episode 3. So again, we're going to look at some gotos and gosubs within assembly language, and we're going to get that mouse cursor program I did on the last episode to run in the background using an interrupt. So looking at gotos and gosubs, how is it done? Well, this first portion here that I've talked about is similar to, this is basically used for conditional statements. So if you're testing, then you would go to another line to execute code. So BRA is branch always, so no matter what the results are in the test bits, it'll always jump to the label that you place there. Doesn't matter, as long as it hits that, it's jumping out of there. BEQ, and notice that I've put basically what these mean. This would be how you would test it within BASIC. You would use the greater than and less than signs. Okay. So BRA is no matter what, doesn't matter. BEQ, branch if the previous result was equal. BHS, branch higher or same value. And BLS, branch lower or same value. B high, branch if it's just a higher value. And B low is branch if it's a lower value. And BNE, branch if it's not equal. So you can see that I put the symbols here of what your testing would have looked like in BASIC. This is how you do it in assembly. Okay. If the branches are too far away within your code, and I believe it's plus or minus 127 bytes forward or backwards, then you'll have to use a long branch. That's basically you just put an L in front of each one of those commands. The thing with using the long branches is that it uses like an extra byte or two to go to that address rather than the shorter version. Okay, I think it's only a byte, but it might be 2. I think it's 1. So yeah, if you're trying to make your program as tight as possible, you're going to want to stay away from using the long branches if you don't need to use them. Another one that I have written in here is jump, JMP, and this is probably the most accurate as saying go to in BASIC. It works the same, except that you're not testing any bits whatsoever. It's very similar to BRA, which is branch always. Jump, it would just jump to that address. Okay. You can save, yeah, like I said, you can save on your compiled space if you use the shorter versions of these commands. One nice thing about LWASM, it'll tell you if you need to use the long branch. So you can go ahead and write your code using the smaller branches, and it'll spit out an error when you go to compile it if you need to change that to a long branch. Okay, so that's a really good feature. So how do you cause these tests for the branches to work? You can do them by comparing results. You can compare A, compare B, compare D. I believe you can also compare the registers, you know, these are just some of the simple ways that you can compare results. So what about gosubs? In assembly we can use JSR, and to return from that gosub you would use RTS. So JSR is the same as gosub, and RTS is the same as return. An interrupt can be set up using RTI, which would be return from interrupt. However, I will show you a hook in BASIC that will not only run faster, it also, I think it also uses it does a VSync or something, so it just looks smoother, okay, than instead of using RTI. So instead of using an RTI in this mouse cursor example, I'm going to be using a jump to a memory address to return out of it instead. Okay. Okay, so back to the mouse cursor program we made last episode. What we're doing in this is we're just putting an interrupt in. So basically when you go to load a program like this, I have it originating at 7,000 in RAM, which is 28,672. So you would actually want to type in BASIC clear whatever string space you're using. I just put 100 in there, and comma 28,672, and this should protect this program from being overwritten from a BASIC program. Okay. Start, again we have a start of our program, and then at the very end of this listing there's the end to our start. Okay. Okay, so the first thing I'm doing, I'm jumping to subroutine set IRQ. So when the program starts up, it's already jumping down here to set up the IRQ. So it'll jump to right here. By doing this this little bit of code here, we're basically loading the value that was currently at one of the vectors for the interrupt. We're going to load that value from BASIC, whatever BASIC set it to, and we're going to store it. I'm going to store it in memory at IRQ. So where you see this IRQ FCB 0-0 store vector, I'm loading that vector value from here, and I'm storing it right here so I can remember where the computer should be jumping to. And this is much faster than calling an RTI return from interrupt. You can test that if you want. I can show you where to put that. right here where I say jump JMP IRQ. Instead you want to go RTI, return from interrupt, and you'll notice that it's way slower using RTI. But I'm using a jump, and we're going back to that vector address that was there. Okay. Back to this IRQ setup. So I've saved the IRQ. I'm loading the label service, and I'm storing that where that old vector address used to be. So now I'm telling BASIC that it doesn't jump to that one place in ROM anymore. I'm telling it to jump to my service routine. So I'm turning the interrupt back on, and then I'm returning from this subroutine. So that basically means every time that interrupt is triggered, BASIC will jump to this service routine right here and execute this code. I'll acknowledge the IRQ by loading a value from FFO2. I don't even have to do anything with that value, just load it. And then I can jump back to the original vector address that was there because I saved it right here. Okay, so that's how that works. So after the setup, we go back to the start of our program. Okay, so it returned here, and now I'm just loading the screen. I'm clearing it, one of my registers, and then I'm storing all of the ASC characters onto the screen. I'm comparing that if I got to the last value 255. This is where we're comparing a result to create a conditional branch. So BLO, that means if branch lower, so smaller than sign, right? In BASIC that would be a smaller than sign. So that means if it's a smaller number than 255, that I would go to LP1, which is right here. So it would create this loop right here. Okay. Now we're loading. After it's done that, it will fall through once it is no longer lower than this value. So it'll most likely be equal. Okay. So now I'm loading the screen again at the start of the screen, and I'm loading my string of text. So that's my string of text is right here. Okay. Notice that I'm using FCN. FCN means there'll be a zero terminating string, which means that at the end of this string it'll report a 0. So while I'm looking at it, the first thing I'm doing is comparing the number 32. That's just a space key. I'm branching if it's equal to LP3, which is here, which means if that space key is showing up, I'm just going to print it to the screen. Okay. I'm comparing the next index load without advancing the index. I'm comparing it to see if it's 0, because I said this is a 0 terminating string. If it's not 0 yet, we can branch back to LP2. So branch not equal. This 0 here means it's not equal to 0. I want it to be 0, right? Then it'll go back to LP2, and when it's a normal character, it should just fall through. This 32 here is just looking for a space key. If it's not, it falls through to this subtract A 96. So this is to fix the ASC code. Everything here is written in lowercase. If we were just to print it as is, it would be a mess. It wouldn't even be words. The only way you can get words to print on the screen, the only ASC characters that are correct are the capital characters. So if I had this all in caps, you'd be able to read it without adjusting the string value or the ASC code. I'm going to do, my next episode is actually going to be string manipulation and getting it to print the correct ASC codes. And I know I also said I was going to jump into converting bytes into human readable. That'll come after that episode. I'm going to try to keep things in order now. Honestly, jumping to this mouse program is pretty far in, it's too far into any kind of exploring. It's a little bit advanced, but I'm gonna jump back after this episode back to less advanced stuff, such as string manipulation and then converting those bytes to human readable bytes, and then we'll take it from there. And again, I also want to show people how easy it is to program on the Game Master cartridge and the program sound generator that Ed Snyder makes. It's actually quite easy to set up for joystick control and you name it. It's great. So I want to also show some of that stuff. And I'm even working on a game project right now. I'm hoping to be releasing that maybe March next year, and it's actually going to be released on a physical game cartridge. I'm going to be able to squeeze that into a 16K ROM space. So I'll be sharing some progress on that as I go along. But for now, I'm going to keep that all secret until I got something really good to show. Alright, so that's basically the program here. So if we go into our VCC, we can set your cartridge, we can insert that drive. Where is it? This one. Okay, so I can load M new PRG, and when you execute that program it should look like this, and you should have a mouse in the background. So it says mouse cursor in BASIC using an interrupt. Okay. Obviously if I start pressing enter, it's going to start trailing and leaving my arrow keys on the screen, okay, as you can see. So it's not a perfect mouse, but if you were to have a fixed screen where it wasn't scrolling, this would work really good, especially considering it's an assembly, so it's fast. It could probably assist a basic program. Again, you'd want to clear, what did I say? We'll just say 2800 for now. This makes it so there's no way I'm going to overwrite my program that's currently running. Okay, this mouse cursor is going to continually run. Okay, I could clear the screen, print mem. Obviously I allocated way too much memory for this little mouse program. But you get the point. You can do plenty of things with this this type of coding. I mean, you can set up variables for scrolling the screen, and kind of what I was doing with previous examples when I was showing the screen scrolling in BASIC. I had an assembly routine that was actually doing the hard lifting. Yeah, alright, thanks for watching.